Hi everyone. In this video, I want to review some concepts through solving some problems. Reviewing the concepts for solve absolute value equations, solve absolute value inequalities, identify polynomial functions and their degree, identify the real zeros of polynomial function and their multiplicity. Also, use the remainder and factor theorems, Descartes' rule of sign to determine the number of positive and number of negative real zeros of a polynomial function, solve polynomial equations, conjugate of a complex number, find domain of rational functions, find vertical asymptote, horizontal or oblique asymptotes for rational functions, and analyze the graph of rational functions. Also solve polynomial inequalities or rational inequalities. So let's start. The first problem, we want to find the real solutions of the equation. The equation that I have is 1 absolute value of 1 minus 4t plus 4 equals 7. So we want to solve this equation for t. To solve the equation, the first step is to keep the absolute value in one side and the other term other side. So we need to subtract both sides from 4. So we have absolute value of 1 minus 4t equals to 17 minus 4. So we have absolute value of minus 4t equals 13. What is the rule for absolute value equality? If we have absolute value of u equals a, then u it's equals to positive a or negative times a. In this case, u is 1 minus 4 times t and a is 13. So I have 1 minus 4t equals to 13 as one equation, and the other equation is 1 minus 4t equals negative 13. Now we have two equations to solve. In the first equation, we subtract 1 from both sides. We have negative 4t equals to 13 minus 1. So negative 4 times t equals to 12. And now if we divide both sides by the coefficient of t, which is negative 4, t equals to 12 divided by negative 4, which is negative 3. So this is one answer for this equation. From the second equation, 1 minus 4t equals negative 13. Again, we subtract 1. So we have negative 4t equals to negative 13 minus 1. So negative 4t equals to negative 14. Again, we divide both sides by the coefficient of t, which is negative 4. It becomes negative 14 divided by negative 4. Negative times negative is positive, and we can divide 14 and 4 by 2. So numerator becomes 7 and denominator is 2. 7 half is t, or you may want to simplify. 7 half is 3.5. there are two solutions for this equation. T equals negative 3 and t equals 3.5. The next question, we have an inequality involve absolute value. Its absolute value of 2 times t minus 6 less than or equals to positive 2. How we solve this inequality? What is the rule for solving inequalities? If I have absolute value of u less than or equals to a, then I can conclude u is between negative a and positive a. In this case, we need to apply this rule. So, based on the rule, I know that 2 times t minus 6 is between positive 2 and negative 2. To solve inequality, these two inequalities at the same time, the first step is to get rid of negative 6. So let's add 6 to all sides of inequality. Negative 2 plus 6. Then we have 2t minus 6 plus 6. And 2 plus 6. As you see, the inequality becomes 2t is between positive 4 and 8. The next step is to divide all sides by the coefficient of t, which is 2. If we divide all sides by 2, then the inequality becomes 2t half is between 4 half and 8 half. So t is between positive 2 and positive 4. If you want to write it in terms of interval, then I can say t belongs to closed interval 2 and closed 4. 2 is closed because it is included. 4 also is closed because it is included. If you look at the interval for solution, among A, B, C, D, E, and F, we know that the answer is between 2 and 4. This is between 2 and 4, and this is between 2 and 4. In part A, we see parentheses. It means that 2 is not included and 4 is not included. But in option C, you see 2, it's included, also 4 is included. So the right answer is C. The next problem is about polynomial. Determine whether the following function is polynomial function. If the function is a polynomial function, state its degree. If it's not, tell why not. Write the polynomial in a standard form, then identify the leading term and constant term. Look at the function. It's 5 times x to power 1 plus x to power 4. What are the exponent of x here? One of the exponent is 1 and the other one is 4. If the function has a variable with exponent natural number, then it is a polynomial if the function has a variable with natural exponent, but the variable is in the denominator. It cannot be a polynomial. For example, look at this. It's 1 over x squared. Although the exponent of x is 2 and is natural, but because it's in the denominator, it cannot be a polynomial. But here, all variables are in the numerator, and denominator is just 1, right? And exponent of our variable are natural number, so it is a polynomial. What is the standard form for this polynomial? The function is 5 times x plus x to the power 4. In the standard form, we need to write the terms in order, in decreasing order. The degree of this polynomial here is 4 because one exponent is 4 and the other one is 1, and 4 is greater than 1. So degree here is 4. To write it in standard form and decreasing order, so you need to write the first greatest term. Here the greatest term is x to the power 4. And then the next term has a smaller exponent than 4, which is 3. We don't have x to the power 3 here. Then is x to the power 2. We don't have x to the power 2. Then x to the power 1. So it's 5 times x to the power 1, and then the constant term. Here there isn't any constant and it's 0. So this is the standard form. What is the leading coefficient? The leading term is x to the power 4. The leading coefficient is coefficient of x to the power 4. Here is 1. What is the constant here? There isn't any constant. So the constant is 0. The next problem is pretty similar to the previous question. The function is x to the power 7/2 minus x to the power 4 plus 4. Is it a polynomial or not? The answer is no. Why it's not a polynomial? Because the exponents of variable x are not natural number. One exponent is 7/2. 7/2 is 3.5. So it is not a natural number. And the other one is 4, which is a natural number, and it is okay. But because x to the power 7/2, this function is not a polynomial. It's not a polynomial, but we can write it in the standard form. If we want to write it in a standard form, because degree of this function is 4, you may write it as negative x to the power 4 plus x to the power 7/2 plus 4. What is the leading coefficient here is -1, and the constant is positive 4. Next problem. Use a transformation of the graph of y equals x to the power 4 to graph function f, which is x plus 4 to power 4. What is the graph of x to power 4? We know that graphs of x to power even are pretty similar to x squared. All of them pass through points 0 and 0, 1 and 1, also -1 and 1. And they are pretty similar to a parabola. X to power 4, it's more narrower than x squared, but again pass through the points 1 and 1, 0, 0, and -1 and 1. Here we have exponent 4 of x plus 4. 4, it's inside the function of x to power 4. When it is inside next to x, it means that you need to transform the function to right or left, depends on this value. It is positive 4, so it means that you need to shift the graph 4 units to the left. So if we shift this graph 4 units to the left, instead of point 1 and 1, if I shift it to the left by 4 units, it becomes 1 unit, 2 units, 3 units, and 4 units. It becomes point -3 and 1. Okay, here I tried to sketch a better graph. This is the graph of x to power 4. As I mentioned, when we have x to power even, it goes through point 0, 0, 1, 1, and -1, 1. Now, instead of x to power 4, we have x plus 4 to power 4. So, although the behavior of x plus 4 to power 4 is similar to x to power 4, but we have a shift. Instead of x, we have x plus 4. So we need to shift the graph 4 units to the left. The point 0, 0, we shifted 4 to the left, so it becomes -4 and 0. This point, 1 and 1, we shift x value, which is 1, 4 units to the left. So instead of +1, right now we have -3, because 1, 2, 3, and 4 units, we need to shift that to the left. And the points -1 and +1, we shifted 4 units to the left. So from -1, we go to -5. So we have this point, -5 and 1. And then we sketch the graph of our function to power 4.